Hello, I welcome you all to this another interesting screencast. We're going to be solving this problem and it reads, the rings A and C each weigh W and rest on the rod which has a coefficient of static friction of mu s. If the suspended ring at B has a weight of 2W, determine the largest distance D between A and C so that no motion occurs. Neglect the weight of the wire. The wire is smooth and the total length of this particular wire is L. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we are told the wire is smooth, so we don't expect any friction between this ring at B and the wire, no friction. Okay, we are only going to expect the weight here, all right, which is 2W. Because of symmetry, we expect the right hand side at A to be equal to the left hand side at A to be equal to the right hand side at C. Okay. All right. So we are going to experience friction at A and at C. All right. So I have partially drawn these or prepared these diagrams on the next page so that we don't consume so much time. So we are going to directly go to the next page to go and fill in the partial diagrams that I've prepared. So here we are. So we are saying there is going to be friction between the rod and the rings, ring at A and C. So we'll have friction force, we are calling Fa, and also friction force at C, we are calling Fb. And the length from A to C, we are being told is D, and this is what we want to find, the largest distance D. Okay, and because of symmetry, we expect Fa to be equal to Fb. So Fa will be equal to FC, sorry, this is FC here, FC, which is just going to be equal to F. And then we expect another force, a normal force here at this point, we are calling NA, and also the other side there we are calling NC. And because of symmetry, NA will be equal to NC, which is just going to be equal to N. And then we've been told the ring weighs W, this ring here at A, weighs W, and so is the ring at C. From its center of gravity, it also weighs W. And the ring at B, we've been told, weighs 2W. Okay. And there is no friction at B between the wire and the ring at B because the wire is smooth. And because of symmetry again, we expect the tension in the wire on the left hand side, the tension T, this T, to be equal to the tension on the other side there. These are going to be equal. Okay, and then I will have an angle in between here which will be which I'm going to call theta, and it will be equal to another theta there. So this wire is free to move about point B because this ring here is behaving like some kind of a pulley, so it will readjust itself so the tension on the left hand side is equal to the tension on the right hand side. So the length of the whole wire we've been told is L, therefore half the length is going to be equal to 0.5 L. Okay, so this one is 0.5 L. All right, so let's cut this wire here we cut it and then just use the right hand side. So I expect a tension there of T, okay, and we said this is theta there, all right, and I have NC, I have FC, and then I have W, the weight of the ring at C. Okay, so if I was to redraw this, I have theta there, then I have this length 0.5 L, then I have this length here, which is 0.5 T. Okay, let me just draw this properly. Okay, so let me find this other part, which is my adjacent. So this part therefore becomes equal to this part here, if I code it H. Okay, so if I code this one H, I'll say my H is equal to 0.5 L squared minus 0.5 D squared. Remember that, right? So if you are to work out this, that's squared. Therefore, my H is going to be equal to, my H will be equal to, if I was to work out this one, it will give me the value, it's going to give me 0.5, okay, to give me 0.5 root of L squared minus D squared, of course positive. So this is the value I'm putting here. I'm putting 0.5 there like so, and then L squared minus D squared. All right, let me wrap this. So we have all the information that we need. Then we can apply the equations of equilibrium. All right, so let's do that quickly. Then summation of forces in the y direction equal to 0. What do we have? We have minus 2w, okay, minus 2w from B, and then the 2w from A and C, which is also minus 2w like so, then plus NA plus NC equal to 0. Since NA is equal to NC, which is equal to N, so we can just call those two N. Okay, so that therefore becomes equal to N. If we made N subject to the formula, N becomes equal to 2W. Alright, then let's go down here on this part that we just sectioned. This part is going to have two components. It will have this one here that we are calling T. This is T sine theta. Then we expect another T there, T cos theta. So that one there, we're going to have the following. We'll have minus T cos theta plus NC minus W equal to 0. NC is equal to N, okay, which is equal to 2W, okay. So therefore what we have here is a T cos theta is equal to T cos theta is equal to W, right? Okay, so we are done with the summation of forces for the both two equations. For the section as well as the whole free body diagram. So we applied the summation of forces on this one as well as this one. Okay, great. Let's now apply the summation of forces in the x direction for both of them. So summation of forces in the x direction equal to 0. What do we have for the main body? We have the following. So we have minus Fa plus Fc, that's all right, is equal to 0. Therefore, Fa, like we said, is equal to Fc, which is just equal to F. And since we are on the very boundary, and we want to find the longest or the largest distance t, we are going to use the friction equation at the very edge, right? So we know to say if slip is not going to, if we do not want slip to take place at A or C, F must be less than or equal to mu s times our n. And we said our n is equal to NA, which is equal to NC, and our F is equal to FA, which is equal to FC. And since we want to use this in our calculation, we just say F is equal to mu s times n. This mu s is the coefficient of static friction on the very rod. Okay. All right. So we know what this F is. Okay, it's equal to mu s times n, and we know what this n is. Therefore, this is equal to mu s. What is n? Is 2w. Is mu s is 2 mu s w, right? So F is equal to 2 mu s w, right? Remember this n here. Okay. Is that fine? Great. Okay. So now let's go down there. So we also know that minus t sine theta, we are here. Okay. Minus 2 sine theta plus Fc. Okay. Fc is equal to 0. And we know that Fc is equal to F. Let me write it down here, I'm lacking space. We know that Fc is equal to F, okay, which is equal to 2 mu SW. Therefore, T sine theta is equal to 2 mu SW. Okay, is that fine? So now we can get this equation. Okay, we can get this equation in t cos theta and t sine theta. We divide them together, right? Okay, so if we did so, then we are going to have the following equation. So we have t sine theta is equal to t mu SW, okay, then t cos theta, this one divided by W. So W and this W and W goes. Therefore, we have t tan theta. We know sine theta and cos theta is tan theta is equal to 2 mu s. But let's come to this here, all right? From this particular relationship, we know that tan theta is also equal to opposite over adjacent, right? So 0.5, then root of L squared minus D squared. This is therefore equal to just D divided by L squared minus D squared, right? So we can equate the two, right? We can equate the two, and if we did so, then we'll have 2 mu s, which is equal to D divided by root of L squared minus D squared. And if we were to work out the two, let's multiply both sides, we square both sides and make d subject to the formula. If we did so, then we are going to have something like this. We have a d squared is equal to 4l squared mu s squared divided by 1 plus 4 mu s squared. And therefore, d will be equal to plus or minus, but we are interested in just the plus, okay? So d is going to be equal to finally just 2l mu s divided by root of 1 plus 4 mu s squared. Right, so that is the value of the d, which is the largest value that we are going to obtain. Okay, that is the largest value of d, that is from point A to point C. I guess we are done, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing, give me a thumbs up, and continue sharing my channel. Bye bye, and see you in my next screencast.